Welcome to the MSJC Internet Authoring Videocast.
Welcome to the CSIS 113B Lecture 3A, covering decisions, specifically the if-else decision clauses. Here's what we will be covering in this lecture. We'll start with a discussion on Boolean types, which is the true-false data type. And as part of that, we'll take a look at the relational operators, because what you'll see is when you're creating decision statements, you'll need to create expressions that need to be evaluated to a result of either true or false. And so generally you use relational operators for that purpose. We'll be taking a look at primitive relations as opposed to the complex data type relations. The majority of your decision expressions will be derived from primitive relations. And then we'll start taking a look at selections, ways that we can set up our if and else if statements to actually have expressions that make decisions that allow our programs to branch in one direction or another. So we'll start out simply with the if statement. That's the simplest way to make a decision. And then we'll follow that up with if-else, and then if-else-if, nested ifs, and then we'll talk about selecting one of several choices. Also short-circuit evaluation, ladder-style ifs, and the phantom semicolon. So we start by taking a look at the Boolean type, which is a primitive data type. And it only has two possible values, either true or false. Behind the scenes, false is being represented by a 0, true is represented by a 1. And then in the example there, in the red box, you see we have two examples. And the first one is we are initializing a new Boolean variable named empty and assigning to it the value of true. So at that point, empty has the value of true. In the second example, we're simply declaring a new variable named full, but we don't assign anything to it. Even though we have not assigned a value to it, the way that the Java language works is it will default that to false. So even though there's no assignment to full at this point in time, the value it does contain is false until we assign it something else, which would be true. It would be the only alternative, right? Now you want to watch your case when you are assigning your values of true or false, because false capital F is different than false lowercase f. Remember that JavaScript is a case-sensitive language. So also remember that all keywords in Java are in lowercase. Now to set up decision expressions, we will need to use relational operators. And so, as the first bullet point states, we use Boolean expressions, which are expressions that will result to either true or false. In the table, then, you see the different relational operators that we can use to generate the results of true or false. So we can check to see if a particular value is greater than another value. In the example on the far right there, you can see we have two integers created, x and y. X is 1, y is 2. In the second line, Boolean z is being created and assigned the results of evaluating whether or not x is greater than y. And x is not greater than y, so that means the value of z would be false at that point. The next operator is the less than operator, checking to see if something is a lesser value than another. Again, we have an example on the far right with x being 1, y being 2. And in this case, when we compare x to see if it is less than y, it is less than y, so that is a true statement. So that means that the z variable would be assigned the value of true. Next is greater than or equal to. So now we're checking to see if it's greater than or the same as. So in this case, when we compare 1 to 2 in the example on the far right, 1 is not greater than 2, nor is it equal to 2. So that is false, and so z will be assigned the value of false. The next operator, less than or equal to, checking to see if it's less than or the same as in value. So with our x being 1, y being 2, we're checking to see is x less than or equal to y, and of course x is less than y, and so that is true. That becomes the value assigned to z. Then we have the equal to operator. Another way to think of that is compare to. And so what we're checking to see here is if the values are the same. In our example, we've got a string x assigned the value of false and a string y assigned the value of true. In the next line then we declare a Boolean of z, and then we want to assign it the results of comparing x to y, and of course those two are not the same value, and so that is false. In the example, we have string x equal to false in quotes because that's a string value, not a Boolean value that's being assigned to x. And then in the second variable, y, we're assigning the string value of true, again in quotes because it's a string, not a Boolean. Boolean z then is assigned the results of comparing x to y. So Boolean z, since x is not the same as y, will be false. So just realize that there is a difference between a string value with quotes around it and the Boolean value of true or false, which you would not place quotes around. When you look at the examples on the far right for each of these operators, notice that the assignment, which is indicated in blue there with the comment, the 2 forward slashes, notice that they don't have any quotes around them because that's the actual value that you would assign to the Boolean value or the Boolean variable. But if it's a string and you want to represent something as true or false, really all you're doing is typing in the words true or false, and so you're putting quotes around them because you want them to be string values. So again, in that last example that we looked at, z, if you were to actually look at it, would be false with no quotes around it because it's a Boolean variable. What we were comparing was to see if those two strings were equal to each other, if they were the same value, and they are not. Then the final operator we look at is not equals. So we're comparing to see if something is not equal to another value. We're comparing to see if two values are the same or not. In this case, if they're not equal to, we'll get a true result. In the example, we've got x is 1, y is 2, and z, the Boolean variable, will be assigned the result then of comparing x to y to see if they are not equal to each other. They are not equal to each other, so the result is true. That's what gets assigned to the Boolean z. Here we're taking a deeper look at primitive relations. It's important to know that each relational operator requires two primitive operands, or values. The result will be a Boolean value, and it only works with comparable primitive types. Most primitives are comparable, so you normally don't need to worry about that. In the chart at the bottom of this slide, you'll see we have two columns, variables and then the comparisons. So we've got an int b equal to 2, an int sh equal to 3300, a double d equal to 2.34, a float f equal to 2.34 f, which means you're assigning it as a float value. You couldn't assign just 2.34 to a float f, you'd get an error. So you have to put the capital F at the end there to indicate that that's specifically a floating point value. And then char C is the capital letter A. So let's see the comparisons. B, is it greater than SH? Well, B is 2, SH is 3300, so that would be false. Then we compare C, which is the capital letter A, to B, which is the number 2, and we're checking to see if C is less than B. So is the letter A less than 2? Well, that would be false, because remember from the ASCII chart, the capital letter A is the value of 65. Next, we're comparing to see if our float f, 2.34, is equal to our double D, 2.34. That is false because a float is only 32 bits and a double is 64 bits. In floats, by the way, you're only getting an approximation anyway. It's really not a good idea to use floats in comparisons. They're approximations, and we've got a little video to show you later to explain why that is. And then the last one, C, our capital letter A, checking to see if it's greater than or equal to D, which is 2.34. That is true because, again, the letter A, it has a value of 65. Here we're talking a little bit about the floating point relations. So floating point numbers are approximations. They're not the exact number that you might expect them to be. So there's a general rule that you really should never compare floating point operands using the equals or not equals operators. A couple of examples for you. You can see we have 0.1 times 10, and then comparing that to the value of 1, Java would consider that to be true. The reality is it may not be exactly 1. Same with the second example. If we're adding 0.1, 0.1, 0.1, 0.1, adding it 10 times there, and then comparing it to 1, again, Java would consider that to be true, but it isn't absolute because, again, floating points are an approximation. And we'll have a video that explains why that flaw exists. Now we'll get you into selection. Relational operators, in conjunction with the Boolean values that they produce, can be used to create Boolean expressions. These Boolean expressions then allow our programs to select alternate code paths based on whether they evaluate to true or false. It's kind of like deciding which direction to head on a highway. Do you want to go to LA? Do you want to go to New York? Well, we could evaluate an expression to make that determination. So the first decision statement that we take a look at is the if statement. So the if statement uses conditions, and conditions are created using relational operators. And then if the condition evaluates to true, then the statements for the true block are executed. Otherwise, they're ignored completely. If you only want to execute one statement, no braces are required. So here's an example. If, and then some sort of a Boolean expression there, do this. That would be the statement. If you want to execute several statements, braces are required. You can see in the example, we've got if with our Boolean condition inside of a set of parentheses. So we always have the expression that we want to evaluate, referred to as the condition, inside of a set of parentheses. And then if we've got multiple statements that we need to have activated if that condition is true, we'll have to have an open curly brace and a closed curly brace to encapsulate our block of statements and then list those statements one by one. Here's an example if statement in code. This is using our Los Angeles or New York example. So the first couple of lines just print to the screen. Do you want to go to LA or do you want to go to New York? If you want to go to LA, enter 1. If you want to go to New York, enter 2. Then we take input from the keyboard. We assign that input to a variable, an integer variable, selection. And then you can see in the next 3 lines we're comparing the variable selection's value to 1, 2, or not equal to 1, and selection not equal to 2. So we're checking to see if they inputted a valid entry. Remember, we're only asking them to enter a 1 or a 2. What happens if they enter a 3 or 4 or some other number? So the first if, comparing that selection, the variable selection to see if its value is 1. In other words, did the user input the value of 1? Then we output, you're going to Los Angeles. If the user entered 2, then that would be the second if selection, or the second if condition would be met. Selection would compare to the value of 2, and so we would output to the screen, you're going to New York. And the third selection, as I said, that's just checking to see that we put in a valid entry or not. So if it's not a 1 or it's not a 2, it's an invalid entry, so that's what we output to the screen. So let's go back one slide just to remind you that here we didn't use the curly braces. But if the first if condition was not true, we ignored the statement after it. If the second condition was not true, we ignored that statement, which would leave only the third selection to be true, or the third condition to be true, which means we would input or output invalid entry. So the point being that an if statement, or I should say the statements that go with the if condition, are only activated, only processed, if the condition for the if is true. So now we're going to take a look at the if-else decisions. So the idea here is, since we're skipping the if the condition is not met, we can have an else condition. So it's an either or. So if the condition is met, run the first statement that you see in the example. If that condition is not met, then run the second statement we see in that example. So true, run the first statement. False, run the second statement. Here's an example of if-else with multiple statements. Remember, anytime that you have more than one statement, you'll need to have curly braces to encapsulate the statement blocks. But the formula is still the same. We're checking some condition to see if it's true. If it is true, then the first set of curly braces there is the statements that will be processed for a true condition. If it's not true, then we go down to the else, where they have the statements in their block, and those will be the statements that are executed if that condition is false. There are several ways that you can indent your if conditions and your else responses. Here's the first style, and you'll notice that in this case what we're doing is we're putting the opening curly brace right after the if condition and then right after the keyword else. Otherwise, it's pretty much the same. You've got two statements, the closing curly, for each case. Here would be the second style. Now we've got that open curly brace underneath of the if and underneath of the else. Everything else remains the same. And then here, the open curly brace is underneath, but both the opening curly brace and the closing curly brace have just been indented underneath of the if or the else. And it really doesn't matter which of those that you use. They're all perfectly legal. They all will work. It's just whatever you are comfortable looking at. Why use braces? Well, they are required for multiple statements. The example you can see will demonstrate to you how confusing it can be when the braces aren't used. So when you take a look at it, it could read if amount sold less than or equal to 35,000. If that's true, then go ahead and output the bonus percentage as 0.035, else output the bonus percentage as 0.075. And then the question is, well, that next line, the last line, does that go only with the else? Or does that get processed in either case, the true or the false case? And we just can tell you that that statement would run in either case, because it basically would look at the format that is in the example there and attribute the first statement to the initial if, the second statement to the else, and then assume that the last statement is not part of the if or the else. But it is hard to read and hard to understand, what's going on. You have to stop and think about it. So if you're going to have multiple statements, use braces. In fact, the rule of thumb is for beginning programmers, always use braces, even if there's only one statement to execute it. I find that actually makes things a little easier to see. It's okay to omit them if you're putting the statement on the same line, because that's, again, you're looking for readability. Now, you can't nest if statements one inside of another. In this example, we have an outer if statement checking the condition to see if x compares to 3, and then a nested if statement inside of that. So if x does compare to 3, then it's going to check to see if z compares to 4, and then there's a true and a false for that statement, for that condition. Now, if x did not compare to 3, then we jump down to the else, and then there's a nested if in that else, Again, checking to see if z compares to 4. If so, outputting y equal to 5, or actually assigning 5 to the variable y at that point. And then if it does not, if it's false, assigning the value of 6 to y. Notice how confusing it can be without braces for delineation. So let's take a look at this code. Question is, what does this code print? If you look at it closely, you see we have an if and then a nested if with a single else. So the question really is, does the else go with the nested if, or does the else go with the outer if? So the rule is that every else is matched with the last unmatched if, which means in this example that else would go with the nested if. This is called a dangling else. So again, using braces, we'll clear that up, make sure it runs the way that you expect it to. Here's an example way that you might choose to select one of several options. It's not the most efficient way. I'll start out by telling you that. So in this case, we're using an if to compare x to 1. If that is true, then there's an action for the value being 1. Then we jump to an else if it were false, and then do another check using an if, comparing it to 2. If it is true, then whatever the statement is for 2 will occur. If that one were false, then we have another else statement and then another check with an if to see if it compares to 3, and then we would perform the action for 3. So that is one way of having several choices, but it's not the most efficient way. So that's why we have the else if statement. So here you can see we are checking to see if the value x compares to 1. That's the first condition. If it's true, then we would perform action 1. Instead of using the else like we did before, separate from the if, you can see we can actually use it together. So the second condition then is identified with the else if clause comparing x to 2. If that's true, then action for 2 will run. And then finally we have our else if to compare it to 3. There the action 3 would run if that's true. If none of those are true, then none of those statements would run. So you can see that's a much more efficient way of doing that. Earlier we talked about the comparison operators. Now we're going to take a look at the logical operators, which allow us to have more complex Boolean expressions and can help us avoid nesting when we don't have to. So a lot of times this can make the code more readable. The first example there is showing the logical AND. So we want to check 2 values in our condition. So we're saying if the balance is greater than 1,000 and age is greater than 21, then go ahead and run that statement. You could write that as 2 different if checks, but again, not as efficient as using the logical operator to do that with. Now there is a term, short circuit evaluation, that goes along with this, which is that as the conditions are being checked, when we're using multiple conditions with the logical operators, if the first condition evaluates to false, then immediately that entire statement is evaluated to false. So in other words, where we have the if a not equal to 0 and b divided by a greater than 12, if a is not equal to 0, then that whole thing is false immediately. No need to go ahead and check the second portion of that condition. But in the second example, what you see is we have an OR. See, in the first condition, both had to be true for the entire statement to be true. So that's why we could short circuit. If just the first part was false, we could short circuit it. With an OR, it does have to check both, because if a is not greater than 10, we're saying OR b incremented not is greater than 7, we are checking to see if either of those is true to make it a true statement. So we're using an and you can use multiple ands, by the way. We're only showing you 2 conditions here. You could use more, but in an and, we're saying all the statements that have the and between them need to be true for the entire statement to be true. So if any one of those, as it progresses through all the and conditions, if any one returns a false, that means the entire statement's going to be false. There's no need to check the rest of them. Whereas in the or, you still have to check both of them, because we're checking to see if either or are true, and if one of them are true, then that whole condition is true. Here's what they refer to as a ladder style if-else. Makes code more readable than traditional nesting. Note that if-else-ifs are interdependent, so be careful to place them in the correct order. For instance, here we're looking at ages, and we want to make sure that we check the lesser ages first. So the first check is to see if age is less than or equal to 7. If so, assign the fee of $8. Else if, so now if the first condition is false, check the second condition, which is to see if age is less than or equal to 12. If that's true, the fee is going to be $10.50. If neither of those statements is true, then the fee is going to be $21.75. The phantom semicolon. This is a common error. You got to remember, decisions are blocks of code, so they need to be terminated by an ending brace. And that is unless you have only one statement to execute, as we've shown you previously. So here is a problem that occurs frequently, especially with beginners. Instead of only terminating statements with the semicolon, some folks have a tendency to terminate the conditional expression. And so that's what you see in the example there. We've got the if with the condition, employees in building compares to 0, and then after the condition a semicolon. So that is incorrect. That is going to throw an error. So semicolons only go after the statements. When you have ifs and else ifs, we collect all the statements into the curly braces, but you never terminate the conditional expression with a semicolon. So to review the lecture that we just completed, we took you through the Boolean types. We talked about relational operators and primitive relations. Then we jumped into selections. We showed you how to make an if, an if-else, and if-else-if. We talked about nested ifs, selecting one of several, the more efficient way of doing that using the else-ifs, short circuit evaluation, ladder style ifs, and the phantom semicolon. Don't add a semicolon at the end of a conditional expression. That's it for Lecture 3A. Until next time, happy coding. If you liked this video, please click the like button and leave us a comment down below. I also would appreciate it if you would subscribe to our YouTube channel. Also, click the notification bell so that you'll be notified when new videos are posted.